Hi guys, welcome back to JayDemy again. Today we are going to discuss about Elastic Container Service (ECS). ECS is one of the very good and popular service in AWS to host your application in a containerized application inside of ECS. So today we will discuss about ECS, and we are going to discuss like practical demonstration also is there. This we are going to create ECS and its required components with Terraform as a code. Okay, so what is ECS? Basically, it's a highly scalable, fast and containerized management service that makes it easy to run, stop and manage containers within a ECS cluster. Let's say cluster of components where you can manage this one. Your containers are defined in a task definition that you use to run individual tasks or a set of tasks within a service. So I don't want to waste much time on theory. I want to go ahead and create, and I want to show you how this ECS will be provisioned and how we will access that with ease of Elastic Load Balancer endpoint. So what are the ways to provision this? To create Elastic Container Service Cluster, there are 4 ways: Elastic Graphical User Interface, or Command Line Interface, or Infrastructure as a Code with CloudFormation, or Terraform. Today we are going to discuss about Terraform. Okay, already we know what is Terraform and what are the main required components we need to launch any service with the cloud Terraform. So I have my folder already. Inside of my folder I'm having multiple resources I have created, and first I'll go with the provider.tf. so here you can use access key and secret access key to create any AWS service within your account. So that's the reason we need to pause this one. If you are running your from any one of the AWS EC2 Linux machine, you just comment out above access key and secret access key and just use shared credentials file, and you just enable this one. You just enable this one and use it, and you will be able to get the credentials of with the help of AWS IAM Role, which is attached to that EC2 machine. For now, for my session, I'm going to give the credentials directly, and let us navigate to a VPC. So I'm creating my VPC, and I'm passing my CAD block. I'm creating my VPC, and what is the availability zones also I'm mentioning here, and I'm calling the how many availability zone count I want to create, either private subnet or the public subnets also. I'm creating what is the CADR range also I'm getting from the main VPC block, and count dot index also I'm just gathering, and you can see the public subnet also I'm creating. And so after creating VPC, we need to have our internet gateways and internet access also we need to provide, and this is also to be routed in the main routing table which we are associating with the subnets. And also we are creating Elastic IP for my gateway attachments, and I'm having a dependency also. This is basically for NAT gateway. I am using this Elastic IP. This Elastic IP I'm using for my NAT gateway, and these are the dependencies which I am actually required to create my VPC file. And I will just go and show you security file, then security groups I'm creating. Here you can see I'm creating 2 security groups, ALB security group. Okay, ALB. So this is we are creating for my application load balancer where I am creating, and that is also needs to reside in my created VPC. So that is the reason I am calling aws.vpc as a service, and local name of my VPC and VPC ID that already I explained in my previous videos also. You just go through it how we will call this one. Just AWS VPC and local VPC name and ID of that one I am calling in my security group. The same way I am just allowing ingress and application port, and this all I have defined in the variables that we will see in a moment. And as well as you can see here egress also, that means outbound also I have allowed from anywhere to anywhere. Resource, again I'm creating a security group for ECS. This basically it will allow traffic to the ECS cluster only comes from the my application load balancer security group. That is how again I have restricted here. And you can see here the security group is AWS security group and ALB, SZ and ID. You can just go here and you can verify AWS security group, ALB, SZ and ID I am passing. So whatever the traffic coming to this ECS, it will only allow on this TCP protocol and this application port, and two port also I have defined, and I am restricting this one. Okay, that and all we will easily configure from the templates. And let us see variables. You can see here I'm defining the region as I mentioned in my VPC. I'm defining how many availability zone count I need. I am going with the 2 availability zones. If you want, you can go with the 3 also. Depending upon this variable availability zone count, you will define the how many number of tasks you need to run within your ECS cluster. That also I will show you. And what is the execution role you want to use for your ECS tasks, and what is the image I'm directly giving. My Nginx is the latest image I'm taking. I'm just using the public image, Docker image, to run this ECS cluster. I'm just getting from the Docker repository, and I'm specifying my application needs to be run on port 80, and the application count also I have defined here. I have taken 2 because of I have chosen 2 availability zone. If you have chosen 2, then you can go with the 2. If you have chosen 3, then you can go with 3 or 6 or 9, like that. You can increase the count of application count. And what is the application health check also I have defined my health check to be under root. And you can see the variable, just a moment, just a second. Yeah, you can see the here this is the main component we are using in ECS cluster. So basically in ECS we have to choose either 2 types, either ECS or Fargate. So the cluster we are managing or Fargate to manage. That is the reason I'm specifying here what is the Fargate CPU and memory also I am defining in my template. Everything I am defining here. And I will also show you IAM role. So IAM policy document, this is the ECS task execution role where we are defining, assume this role to ECS tasks, AWS, Amazon.com. This is the my service name, and the task execution role is this one. This we are creating this role, right? From this we are calling that execution role, and where task execution role we are defining here, and the policy document. This is the policy document. We are again just calling from the execution role. This is the role we are calling, and IAM role also we are just using here, and the ARN of policy also we just need to use, then only it will actually take. And this is actually not required, just I have just taken for reference. And the ECS we will see in last, and we can also see CloudWatch logging group. So we have created a log group under ECS or test app, and the retention also we have kept this as per your requirement if you are working in a production. And CloudWatch log stream also we need to create, and the log group name we need to actually add here. This is the log group name we are just adding to stream the logs here. And also I want to show you ALB, application load balancer. I'm creating a load balancer, and this is I'm just creating this load balancer in public subnets, so it will get the public subnet IDs. And the security group also I am calling where I am creating the security group in this security group file. From there I am calling, and you can see what the target group also required to create my load balancer. So that is that one I have mentioned, and where my VPC ID, where do I need to create this target group, everything I'm defining here. And what is the health check and other required components I'm defining. And the main important thing is main important one is a listener, ALB listener, where the listener is the main part of ELB. You need to create or define the listener. I'm creating a listener, and from where I need to attach. So this is my load balancer AWS ALB.id, and the port and all I'm giving in variables, and I'm using protocol HTTP. So in production we will use HTTPS, So that time what you need to do, you just modify here port HTTP to HTTPS, and SSL policy you need to enable, and what is the latest policy, TLS policy you need to use that one here, and certificate ARN. This is the certificate which you imported to your AWS certificate manager. That ARN you need to pass here. Enable, yeah, a comment also I have given for your reference. Enable about to if you are using HTTPS listener, and change the protocol from HTTPS to HTTP. Actually this is HTTP to HTTPS. I'll save this one, and default action forward to target group ARN. It will directly forward to target group ARN. In this listener we need to attach the default action to my target group which I have created the above. And coming to the auto scaling, yes, you can before going to auto scaling I want to show you ECS one, then you will be able to understand why this auto scaling we definitely need. So cluster name, again this is usual, and data. So here I am just giving the template file. I'm passing the template file as a test to remember locally, and template equals to I'm just defining file. So if you want to call any file, you just need to use this file as a attribute, and then you need to define this one here, this dot templates image.image.json. In the same folder I'm having templates, under that one I'm having image, under that one image.json is there. We will go there within a short time and we will see very quickly, and what is image.json also we will have there. So, and I'm defining a variables, that is what is the image, port, CPU, memory, everything I'm defining over here. And you can see here resources. This is the main things, AWS ECS Task Definition and ECS service. So before that I want to just explain you what is the task definition, what is the service, and what is the Fargate. Then we will come back here. So basically task definition, to prepare our application to run on our Elastic Container Service, we need to create a task definition. Task definition is a set of parameters we are passing in a JSON format in a file, text file. That file only I have shown you in the template dot image, under that folder image.json I have just shown. The task definition can be throughout of a blueprint of our actual application, and then we can define how many containers we need to maintain that from our application. It specifies the various parameters from the application in the JSON configuration. That is what a task definition. What is a service? Basically ECS service allows you to run and maintain a specified number of instances of a task definition. So we are defining the how many containers you want, that will take care by a service. For that reason we need to create a service also simultaneously in Amazon ECS cluster. If any of your tasks should fail due to any other reason, or you stop, or it is stopped by any other reason, for the Amazon ECS service, the service is having a scheduler that will automatically launches another instance of your task definition to replace or to maintain a minimum or design number of tasks in the service. It will launch additional services. In addition to maintaining the design number of tasks in our service, we need optionally run your service behind a load balancer. That's what I have shown you, application load balancer. That load balancer evenly distributes traffic across the tasks that are associated with the service. That is what service is basically. And what is Fargate? Fargate is a technology that you can use with Amazon ECS. It's basically to maintain containers without having to manage any EC2 servers in a cluster or a cluster of Amazon EC2. So if you are creating a cluster, you are the responsible for to maintain the cluster. If you are choosing the option as a Fargate, you don't want to manage any servers or any EC2 instances which you are going to deploy your applications. With AWS Fargate, you no longer have to provision, configure, or scale the clusters in virtual machines to run our task definition or containers. This removes need to choose server type, decide when to scale down. This and all is taken care by Fargate. When you run any task service with the Fargate launch type, for launch type as a Fargate you need to choose. That I will show you where I have chosen this launch type as a Fargate. Then your package or your application in containers specify the CPU and memory requirements to run the Fargate. That I have already shown you in a variables how much I have define the networking and IAM policies, which is actually run the tasks. So service role is required to run. Each Fargate task has its own isolation boundary, does not share the actual underlying kernel or CPU resources of our actual EC2 or any other tasks. So it is having its own boundary, so it won't depend on any other tasks. Okay, that is what AWS Fargate, actually ECS Fargate. So quickly we will what we will do. So I will just Terraform init. We'll do Terraform init. So it is initializing the backend, so everything is up to date, and we will perform Terraform plan, and we will see if you have any errors in this files or in this area, you will able to understand. Okay, I think there is no issues. 29 to add, and ALB hostname equals to known after apply. This where we are getting, I will show you. Before that, I want to quickly show you. So if you see my EC2 dashboard, nothing is there like load balancer, instances, other any security groups. Okay, and I will go to Elastic Container Service. This is actually Elastic Container Service, how you can look. And if you want to start from here, you can get started and you can click and create. That will be easy. And in our case, we are creating with Terraform. So ECS clusters. So as of now, there is no cluster to display. So let us wait for some time. We will just spin up and it will come. And meanwhile, just I will go Terraform apply. And then we will verify remaining resources which it will create before and after. Yes, I will approve this, and then I'll go here. You can see here my load balancer also is not there, and I'll also open one more tab for my VPC section where we will able to see VPC also it's trying to create. See, just now it is initiated and VPC is trying to create. This is the VPC it is trying to create. This is what I given my VPC area. You can see here, this is what it is trying to create. And I want to show you ECS task, right? So yeah, we have defined the ECS task definition and what is the role it needs to be taken and where this needs to be run. Without AWS VPC also you can define. This will directly deploy into their AWS managed VPC. Required compatibilities. Here you need to maintain either Fargate or ECS cluster. So CPU and memory container definition also we need to define. See, this is the template file, and what is the app you are giving and rendered you need to specify. And this is the another section where we are defining the ECS service. This service is directly linked with cluster. The cluster name also test cluster we are giving, and task definition. The task definition is this one. This is the task definition, and we are calling this is the task definition name, and ARN we are calling and we are attaching here. And desired count, what is the desired count we have given? That is 2 also we given. And launch type, this is the important type, important one you need to specify in your launch template. This I can say in your service section, either if you are creating in console or here, anything you need to define. And network configuration also you need to give the security group. Security group already we have created and we are assigning. This assigning public IP is true. If you require, you can go ahead and give it, or else if you are running behind a load balancer, you don't want any public IPs. Okay, one more thing I want to highlight here. So this again already we are just using a load balancer. This under ECS task definition we are said, right? If you want this your service definition to be more robust, then you need to go with a load balancer where you are defining AWS ELB target group. You are just directing to the target group. Whenever any user hits is there, by defaultly additionally with the help of AutoSacling Group, your containers will be added to your target group. And we have given here depends on. So this ECS needs to be depend on our AWS listener. That means first our AWS load balancer need to configure, then our ECS cluster need to be created. AWS ALB listener and IAM role and policy attachment. These two with the dependencies I have specified here. And the final one I want to show you here, outputs that JSON DF. So here just I'm using the output ALB hostname, and value will be ALB dot this is the local name and the DNS name we are getting. Yeah, as you observe here, we have output ALB hostname equals to my app load balancer. Let us copy that, go ahead and paste in browser. Try to remove both the codes in front and at the end. Just delete it. Let us try to access this. Here we go. We have to see how this is amazingly worked. So welcome to Nginx. So now we have deployed with the 5 minutes of our scripting, we have directly deployed Nginx application into our EC2 cluster. Let us see. You can see here there is no tasks pending. Two tasks is running. Why this two tasks is running? As we defined task definitions is two. Just my app where I have defined these tasks, I'll just go ahead and I'll quickly show you how this is actually deployed the two tasks. You can see here my task definitions. Where is this? Yeah, this is my task definition. Task definition test-df, and the name is test app-task. Test app-task. So let us click on this. In this task we have two services, two containers are running. Task definitions, both are in active mode. Let me go to world experience so it will be very clear, and I will just go ahead, clusters. Yes, you can see here my application cluster, one service is running, two tasks is already running. Yes, I'll go back here. See, this is my service name, test app service. If I go here, you can see the status also active, and task definition is, this is the task definition version 2 I have taken, and the replica is desired count and running count, and there is no pending count. This is my desired count. I can define maximum count also, minimum count, like then it will actually create. If you see here tasks, there are two tasks is running. This is the task 2 and another one is task. Both are the two tasks running. The test app task 2 is the version of my JSON, that is a Docker image which I have deployed. This is two times I have deployed, so that is the reason it is showing 2. And the platform is ECS, and the launch type is Fargate, and it is showing 1.40 is the latest version of tasks. You can go and you can check with the task ID what all we have defined, that you will able to see. Here you can see the public IP. What we have defined there, public IP enable equals to true we have defined, right? Just I will access that also. I'll show you. So whenever you are trying to access the public IP, by that also you will able to access your Nginx image, Nginx application, I can say. And what else we can see in ECS? Those are the things we need to verify, and runtime also, everything you can see here. Task definitions and services we need to basically think. If you want to create a new task, you can create from here. Yeah, that's what I was saying, right? Either Fargate or EC2 you need to define. If you are defining EC2, you are the owner and you are maintaining all the aspects. So you don't want to maintain means, then go ahead with Fargate. That will be straight away solution actually. And let us see the other services which are created by our Terraform. See, there is no IPs, load balancer 1, and I will go again. See, this is now provisioned, I think provision, and I was saying, right, listener is important thing. You can see here listener is created here. You can see the listener is created, and it is forward to target group. So that is what we are default and forwarding to default security group, default target group. Just click on this target group and just navigate down and click on the targets. Target is nothing but where our actually our Nginx server is running. You can see here you will able to see only IP address of each task each task. So if there is no instance is running because we are using Fargate as our container orchestrator, I can say. With the help of that one, it is trying to create a IP address that I can show you. This is not creating any EC2 instances, that is creating a interface that I will show you. Network interface. I'll just fetch with the IP. You can see here, this is the interface which it is created by our Fargate, and it is just actually solving the actual request. That is how Fargate will backend, it will manage our things. This is the VPC which we have created. Okay, just I'll refresh this, and yes, this is the VPC and other subnets and all it is created. If you can just go through it and you will able to understood that is basically port 18. So this is how you actually deploy your application into ECS and how things will work. And if you have any doubts, please feel free to ping me, comment me in YouTube comment section, and I'm going to provide you all the Terraform templates in my GitHub. That links also I'll provide you in YouTube description. So don't forget to destroy once you have created anything you don't want to keep always running. If you are running it, it will actually charge without any notification also. So make sure once your things are tested successfully, then you are going to delete the resources. I hope it is clear. All the templates I have given overview what is the actual contents of each template and how this is actually going to work. Just destroy and give the yes. Once it is done, then it will try to destroy all the services which we have provided from the console CLI template with the Terraform. Thank you guys. Please go through it and you just get the template from my GitLab. I will provide you the links in my description. Please do like and share and subscribe. Thank you.